Hello again, everybody. Today we're doing our physics talk, this time Model 2, describing motion and speed using an equation. So now we're going to do some mathematics. Make sure, again, take good notes. Anything that's pretty much on each slide, try to record whether it's the equation or how I go about solving a problem. So our learning objective, instead of using strobe photos like last time, now we're going to actually use an equation to describe speed. So our job is to use mathematical and computational thinking as part of our science and engineering practices, and we're going to look at patterns, scale, and proportion and quantity when doing our mathematics. So a reminder again from the chapter challenge, you're expected to explain what factors affect following distance, braking distance, and total stopping distance. And part of this section will teach you how to actually use the formulas to do some calculations for that. Speed, of course, is one of those factors, and of course average speed is the total distance traveled, by definition, divided by the time it took to travel that distance. So here it is right here, V average, the distance traveled on top, divided by the time on the bottom. So those are the symbols. So V average right here is our average speed. The change in D, which is delta D, is a change in position or distance traveled. And on the bottom, delta T is a change in time or time elapsed. Now, when looking at this new symbol, delta, you might have seen this in mathematics, but delta is the Greek symbol delta. In math, in science, it means change in. So this is the change in distance or change in position. This is the change in time, and those things can be just entered in. So as an example, sample 1, problem 1, if you drive a distance of 400 miles, which is about 640 kilometers, in about 8 hours, what is your average speed? So let's say here's my car, this is my starting distance, location, and I travel 400 miles all the way across to over here in a total of 8 hours. And when I look at my given, since I wrote these numbers down in these locations, this is distance, so I use delta D to equal 400 miles, delta T equal to 8 hours, and then I ask myself, what am I trying to find? Well, it says if you're driving a distance, what is your average speed? So I list on my find average speed. And really, you need to do this as part of your problem-solving techniques by writing always what's given, connected to the variable and the number, variable and number, what you're trying to find, looking for the variable you're looking for, and of course, then you have to figure out the formula. Well, we only have one formula so far, at least for this chapter. V average is equal to delta T over delta T. And so you can see the 400 miles here. We're going to plug that in there. And the 8 hours, we're going to plug that in down there. And so when we do some algebra, 400 miles on top, 8 hours on the bottom. And when you divide those two, we get 50 miles per hour or 50 mph. And that becomes our answer for sample problem number 1. So be able to really plug in numbers based on writing down what you know, so you know what to put in the formulas. That's really going to be important. Now, average speed versus instantaneous speed. In general, by definition, average speed only cares about total distance and total time traveled. Doesn't care if you stop, get lunch, speed up, or slow down. So as an example, the 400-mile trip, that's basically from San Diego to Las Vegas. And there's multiple routes you could take to get there. You could take the yellow route, you could take the red route, you could take the green route, or even this blue route over here. So there's many different routes you could take to get there, but all that matters is that you travel 400 miles in 8 hours, and so that would be how we calculate that average speed. However, along the way, you deal with instantaneous speed, which is the speed at any given moment. And you might be stopped over here in this corner, you might be driving really fast on the straight portion, you might be even driving really fast on this yellow portion right here. And the car's speedometer really tells you instantaneous speed. So make sure you understand the difference between instantaneous versus average speed. Okay, so instantaneous is what your speedometer tells you, and average really is calculated as long as you know the total distance and the total time, you can calculate that. All right, understanding motion, model number 2. Again, sample problem number 2. Let's say you're traveling at 35 miles per hour, which is about 50 feet per second, and your reaction time is 0.2 seconds. It says calculate the distance you traveled during your reaction time. Now you'll notice on here I don't ask for which particular distance. I could do it in miles, I could do it in feet, it doesn't matter. But when really looking at the given, since this is my velocity or speed, V average is 35 miles per hour or 50 feet per second. I'm writing both of them down because I don't know which one I want to use. Delta T is the time you're going to be traveling, 0.2 seconds. And so when I look at what I'm trying to find, since it says calculate the distance, And there it is right there, distance, which is delta D in my formula. And I look at this same formula that we did last time. This time, however, I got to decide which numbers I really want to use. And in this case, since this is already in seconds, I'm going to use the speed given in feet per second. So I'm not going to try and convert this guy to any other miles per second because it's just too much work. I already have it in feet per second. I can figure out the distance in feet. So use that information accordingly. So then I'm going to plug in the 50 and then into my V average. I'm going to plug in the time down below, and really delta D is what I'm looking for. So when I set that up, it's going to look like this. Plugging in those numbers, I get 50 on this side because that's the V average, and I get my 0.2 seconds down on the bottom because that's the time. And now I just got to do some algebra. The question is, do you remember how to do the algebra for this? If you're looking for delta D or X up here, how do I get that by itself? Well, in algebra, the opposite of division is multiplication. So I'm going to multiply both sides by 0.2 seconds. And then, of course, when I do that, my 0.2 seconds cancels, and I wind up getting, actually, the seconds also cancel. Looks like I forgot my units over here. And you wind up getting 0.2 times 50 on your calculator, which is 10 meters. And that becomes the distance that they travel during that reaction time. So imagine that. You're just traveling 50 feet per second, which is only 35 miles an hour. But in a 0.2 seconds time, I've traveled 10 meters, which is a lot of distance when you think about how many, the length of 1 meter. So it's really important that you're really paying attention whenever you're driving, because even a 0.2 reaction time, which is very fast, can, result in a big change in distance if you're not paying attention. All right, so the last thing we want to talk about is the last example, sample problem number 3. It says in an automobile collision, it was determined that a car traveled 150 feet before the brakes were applied. So when looking at that, if the car had been traveling a speed of only 40 miles an hour, which is 60 feet per second, what was the driver's reaction time? In other words, the time it took to apply the brakes. So moving his foot from the accelerator to the brakes, he traveled 150 feet. And we want to know the driver's reaction time. So you're not going to use the old formula from the first section to do this because this is a different kind of motion. Witnesses say the driver appeared to be under an influence of alcohol. Does your reaction time data support the witness's testimony? Let's find out. So again, looking at our given in this case is, I put the wrong number here. This is supposed to be 40 miles per hour right here. And of course, which is 60 feet per second. And the distance traveled is 150 feet. And when you plug in what you're trying to find, when they're trying to find time, so in this case, the reaction time is delta T. And the formula I'm going to use, of course, is the same formula. So let's go to the other screen real quickly. So there's the same formula. And we're going to plug in the numbers. V average is going to be, again, because this is already in feet, and this is in feet, I'm going to use the one with feet per second. That's why I forgot this typo. That's my fault. Sorry, I apologize for that. Plug that in. 60 goes in here. 150 goes right there. And then I'm looking for delta T. So how do I solve for a variable that's in the denominator? So in algebra, typically what you do is you set these up as two fractions on both sides. So let me rearrange it. So the 60 is on top, seconds on the bottom. And I can actually cross multiply here. So if I cross multiply, I get the 60 feet with the delta T and the 1 second down below with the 150. So I move that across, and you can see the cross multiplication happening here with those two together. And these two together give me this one. And of course, now I have my variable out of the denominator. How do I solve for it? If I'm multiplying something to it, the opposite multiply is just to divide. So we're going to divide 60 on both sides. Set that up. There you can see the 60 being divided on both sides. This will cancel out the 60 and the feet on this one as well, leaving me with delta T by itself on the left. And I just take my calculator, 150 divided by 60, and I get 2.5, and the units left over is seconds, 2.5 seconds. So there's the answer. And so then what did I again calculate? Oh, I calculate reaction time. 2.5 seconds? What? That's craziness. Now let's look at question part B. It says witnesses say that the driver appeared to be under the influence of alcohol. Does your reaction time data support the witness's testimony? And the answer to that would be, well, yeah, 2.5 seconds is very slow compared to what we got in the lab investigation. So it is highly possible that that person could be under the influence of alcohol if their reaction time was really that slow. All right, so that's all I have for today. Hopefully you wrote down all those details. Really, it's all about given, find, and formula. Start with those, and then you can solve any problem. If you have any questions, tutoring always on Monday. Have a great day, guys.